The following question reads, 7 librarians F, G, H, K, L, M, and Z are being scheduled for desk duty for 1 week, Monday through Saturday. The librarians will be on duty exactly 1 day each. On each day except Saturday, there will be exactly 1 librarian on duty with 2 on duty on Saturday, subject to the following constraints. So we have our inventory. Our 7 librarians, F, G, H, K, L, M, and Z. We're scheduling desk duty for 1 week, Monday through Saturday, and we know that the librarians will be on duty exactly 1 day each, and each day except for Saturday, there will be exactly 1 librarian on duty with 2 on duty on Saturday. So we're going to have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and another spot for Saturday up here. And now we can hit the rules. Rule number 1, H must be on desk duty earlier in the week than L. Okay, so H is before L, meaning L can't be on Monday, because if L were on Monday, there'd be no place for H to go. And H can't be on Saturday, because if H were on Saturday, there'd be no place after Saturday for L to go, because we're just doing it from Monday through Saturday. Now, rule number 2. Both Hill and Moore must be on desk duty earlier in the week than Gomez. So, we have H and M before G. Okay, so that means that G is not on Monday, and that means that H and M are not on Saturday, and we already have H not on Saturday, so M is not on Saturday. And now we can combine rules 1 and 2. We know we have H and M before G. We also know that H is before L. So that means that H has 1, 2 things after it, meaning H also can't be on Friday. Rule number 3, F must be on desk duty earlier in the week than both K and M. Okay, so we have F before K and M, meaning M and K can't be on Monday, and F can't be on Friday or Saturday. And now we can add rule number 3 to our chain. We know we have F before K and M. So that means that F now has at least 1, 2, 3 people scheduled after her. So F also can't be on Thursday. Likewise, we know that G now has 1, 2 people at a minimum before her. So that means G also can't be on Tuesday. All right, rule number 4, K must be on desk duty earlier in the week than Z. So K before Z. That means Z can't be on Monday, and K can't be on Saturday. And we can add this to our large chain. K has Z after it. So this means now F has at least 1, 2, 3, 4 people scheduled after her. So that means F also can't be on Wednesday. And likewise, we know that Z has at least 1, 2 people scheduled before her, so Z can't be on Tuesday. And now the last rule, rule number 5, unless L is on desk duty on Saturday, L must be on desk duty earlier in the week than F. Okay, so if L is not on desk duty before F, then L must be on Saturday. If L is not on Saturday, then L is before F. So that means that if L is not before F, L is on Saturday. And if L is not on Saturday, then L is before F. So let's draw those 2 out. We know our first option is when F is before L, which means from rule number 5 that L is on Saturday. Well, we have our large chain, and we know that L is on Saturday. And if we were to write it out sequentially, we know L is on Saturday. We know the only other 2 librarians that could be on Saturday with L are G and Z, because G and Z are the only ones that don't have any librarians after them, and we have all 7 librarians depicted in the chain. So this is going to be either G or Z. We can use the same method to see who's going to be on Monday. The only 2 librarians that don't have anyone before them are H and F. So that means we'll either have H or F on Monday, and that's all we can deduce. Now, what about when L is before F? Well, if L is before F, we know we have our LF. We know rule number 1 still stands, so we have H before L. Rule number 3 still stands, so we have F before M and K. We know that G is after M, and we know that Z is after K. So that means we're going to have H, L, F on Monday, Tuesday, Wednesday, respectively, and then the only 2 that could be on Saturday are G and Z, and then we have a binary of MK on Thursday, Friday. So these are our 2 options that we've deduced based off of primarily rule number 5 and then combining all the rules together to create our larger chains. And so the last thing to note, looking back at our main setup, we see that we can't have L, G, M, K, or Z on Monday. That means the only 2 options, which we've already basically deduced that are going to be either H or F, we can place here just to have in our setup. Likewise, for Saturday, we cannot have H, M, F, or K, meaning our only 3 possibilities are going to be G, Z, and L. Okay, so that's our setup, our rules, and our deductions. Let's go ahead and hit the questions.